Question number 5 is, what would a system be of coordinates be like if we did not have negative numbers? Would this system allow us to locate all the points on a 2D plane? First we understand the signs of the coordinates of four quadrants. This is the first quadrant, second quadrant, third and the fourth. What is the signs of the x and y coordinates in the first quadrant? Positive. Okay, both the coordinates of first quadrant are positive, and in the second quadrant x coordinate is negative and y coordinate positive. In the third, both coordinate x and y are negative. In the fourth quadrant, first one x coordinate positive and the second y coordinate negative. Okay, now according to the question, if we did not have negative numbers, okay, see in the except first, second, third and fourth, all are their negative numbers, negative coordinates. But we did not have negative numbers, so the coordinates could only be in the first quadrant or in the origin, correct? So the coordinates could only be 0 or positive. That's why we locate the points only in the first quadrant or in the origin. Therefore, such a system would not allow us to locate all the points on a 2D plane. So let's write the answer. If we did not have negative numbers, then the coordinates would only be 0 or positive number. Okay. That means we can only locate the points in the first quadrant or in the origin. We can locate the points only in first quadrant or in the origin, because the quadrants of origin is 0, 0. Okay. Therefore, that is the answer of the second question. Would this system allow us to locate all the points on a 2D plane? Such a system would not allow us to locate all the points on 2D plane. 2D plane. That is the answer of the question 5. Question number 6 is, are the points M whose coordinates are -3, -4 and the point A whose coordinates are 0 and 0 and the point B, the coordinates are 6 and 8 on the same straight line? Suggest a method to check this without plotting and joining the points. So how it is possible without plotting and joining? The given 3 points are on the same straight line or not? How do you know? Using distance formula we can check. Okay. So what is the distance formula? You know, distance formula. AB equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square is the distance formula. So the given points M -3, -4, A 0, 0 and G 6, 8. First we find MA. What is the distance of MA? So using distance formula we have to find out. So here x2 is 0, minus x1, that is minus 3, okay, whole square, plus 0, y2 is 0, 0 minus y1, y1 is minus 4, whole square, 0 minus minus 3, 0 minus minus plus 3, so 0 plus 3, 3, 3 square 9, plus 0 minus minus 4, minus minus plus 4, that means 0 plus 4, 4, 4 square 16, means 25, and square root of 25, 5, is 5 units. So the distance of MA is 5 units. Similarly, distance of AG, square root of, this is A, this is J, x1, y1, x2, y2. So the formula, according to the formula, 6 minus x2 minus x1, that is 6 minus 0 whole square plus 8 minus 0 whole square. So 6 minus 0 6, 6 square 36, plus 8 minus 0 8, 8 square 64. So this is 100 equals to square root of 100, 10 units. Okay. And M and Z, what is the distance of M and G? Square root of 6 minus minus 3. So minus minus plus 3 whole square plus 8 minus minus 4. Minus minus plus 4, 6, 8 minus 8 plus 4 whole square equals to 6 plus 3, 9, 9 square 81, plus 8 plus 4, 12, 12 square 144. Okay. So total 225. Square root of 225, 15 units. Okay. Now see mg plus ag. MA plus ag. What is MA? 5 unit. AG 10 unit. 5 plus 10, 15. And equals to mg, that is also equal to 15 units. So we can write, since MA plus AG equals to mg, that is 5 plus 10 equals to 15. Therefore, we can write M, A and G lies on same straight line. Okay. Because this is suppose MA, okay, and this is MA and this is AG. MA we are getting 5 unit and AG 10 unit. If you add them, get 15, and MG equals to total 15 unit. Okay. So by plotting also you can check our prediction or our answer is correct or not. So this is only for the graph, no need to write, because the question is without plotting. You have to find out the given 3 points are lies on the same set line or not. So the next question is question number 7. Question number 7 is, use your method from problem 6 to check if the points R, B and C whose coordinates are given are on same straight line. Now plot both sets of points and check your answers. So same type we have to do. The same way we have solved here using distance formula. So what are the given points? Are minus 5 minus 1, B minus 2 minus 5 and C 4 minus 12. So using distance formula, first find RB. R and B. So x1 y1, x2 y2. Formula is x2 minus x1 whole square first. x2 minus 2 minus x1 minus minus plus 5 whole square plus y2 minus y1 minus y2 is minus 5 minus x1 minus minus plus 1. Okay. So solve this. 1 minus 2 plus 5, that is 3, 3 square 9, plus minus 5 plus 1 minus 4, minus 4 whole square 16. So that is 25. Square root of 25, 5 units. Similar way, BC. What is the distance of BC? So this is x1, x2, and this is y1, y2. So x2 minus x1, that means 4 minus x1 minus minus plus 2 plus minus 12 is y2 is minus 12 minus x1, sorry, y1, y2 minus y1, y2 is minus 12 plus minus y1 minus minus plus 5 whole square. So 4 plus 2, 6, 6 square 36 plus minus 12 plus 7 minus minus 12 plus 5 minus 7, minus 7 whole square 49. So total is 85, square root of 85. Keep it like that. Next, you have to find out the distance of R and C. R and C. Okay. RC equals to square root of, in RC, what is x2 and x1? 4 is x2 and minus 5 is x1. So 4 minus minus 5, minus minus plus 5 whole square plus y2 minus y1, y2 is minus 12, y1 is minus 1. So minus 12 minus minus plus 1 whole square. So first one, 4 plus 5, 9, 9 square 81 plus minus 12 plus 1 minus 11 whole square 121. So total square root of 202. Keep it like that. So units. Now observe, RB equals to, we get 5 units, and BC square root of 85, RC square root of 202. So if you add any two RB plus BC, this is not equal to the third one, RC, correct? So similarly, that means that given 3 points does not lie on a same straight line. So you can write, if RB plus BC equals to RC, if but 5 plus square root of 85 does not equals to square root of 202. Therefore, R, B and C are not lie on same straight line. This is our answer. Okay. Now the another point is in this same question. Now plot both sets of points and check your answer. You have to plot this given 3 points and check the answer is correct or not. If you join these 3 points, if you join these 3 points, you see B point is not lying on the line. Therefore, R, B and C are not lying in the same straight line. So our answer is correct. Question number 8 is, using the origin as one vertex, plot the vertices of a right angle isosceles triangle. So first we take origin as a one vertex. So this is the origin 0, 0 whose quadrants. Since it's an isosceles triangle, we know that in isosceles triangle, two opposite sides are equal. So if we take from the origin same distance in the x-axis, suppose I am taking 3 units, 1, 2, 3. Okay, and in the y-axis from the origin also same distance, 1, 2, 3, 3 units. So we are getting two equal sides. If we join these two sides, 2 points, then you get a isosceles triangle. And what type of isosceles triangle? This is a right angle isosceles triangle, because in the origin it's forming a 90-degree angle. So let's name it. This is O, this is A, this is B. So AOB triangle is a isosceles right angle isosceles triangle, where angle AOB is 90 degree and OA equals to 3 unit, OB equals to also 3 unit. Therefore, angle AOB equals to 90 degree and side OA equals to OB equals to 3 units. Therefore, triangle AOB is a right angle isosceles triangle. The second part of this question number 8 is an isosceles triangle with one vertex in quadrant 3 and other in quadrant 4. So we have to create an isosceles triangle whose one vertex always been in the origin, and the second one is in quadrant 3 and the third one is in quadrant 4. So in that way we have to create an isosceles triangle. So let's create one vertex should be in origin and another one in third quadrant. This is third quadrant and this is fourth quadrant. Okay. So in the third quadrant, anywhere we can take the second vertex of the isosceles triangle. Suppose I am taking here. Name it P. Now check the points. Check the quadrants of this point. 1, 2, 3, 4. Minus 4 is the x coordinate and y coordinate 1, 2, 3, 4, 5. Minus 5. So minus 4 and minus 5 are the coordinates of point P, which is the second vertex of the isosceles triangle. Now the important point is, since it is an isosceles triangle we have to create, so the third vertex of the angle should be the mirror image of the second vertex. So second vertex is P, whose coordinates are minus 4, minus 5, and the third vertex is in the fourth quadrant. So it should be the mirror image of P. So what would be the mirror image? What is mirror image actually? If two points are there, their x coordinate, either x coordinate or y coordinate are same, and one of them are different in sign. So since it is P is minus 4 minus 5, so the next third one should be 4 minus 5, because 4 and minus 4 they are different in sign, x coordinate but different in sign, and minus 5 is the same, y coordinate should be same. That is the mirror image. What is the mirror image of minus 4 and minus 5? 4 minus 5. Okay, it would be like that, minus 4 5 also, but since the third quadrant should be in the fourth quadrant, so it should be 4 minus 5. So in that way you can judge. So third quadrant, let's plot it. 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. So here is the third vertex of the isosceles triangle. Okay. Now join these three points. First O to P, next P to, let's name it Q. Okay. P to Q and Next, join O to Q. Okay. Now you see OPQ is an isosceles triangle, correct? Where OP and OQ are equal side. Why equal side? Because P and S, P and S and Q are equal because PQ are the mirrored images to each other. So PS distance and SQ distance are same, and OS is the common perpendicular. So by simplicity rule we can say that OP equals to OQ. That's why OPQ is an isosceles triangle, because OP and OQ are the two opposite sides and also which are equal. So OPQ is an isosceles triangle. Are mirror images to each other. And triangle OSP and triangle OSQ, in triangle OSP and OSQ, OS equals to OS common side, and PS equals to QS. So they are the mirror images P and Q. By CPCP rule, so that OP equals to OQ. Therefore, triangle OPQ is an isosceles triangle. Let's solve the next question. Question number 9 is, the following table shows the coordinates of points S, M and T. In each case, state whether M is the midpoint of segment ST. Justify your answer. So here we are using midpoint formula. You know the midpoint formula? What is midpoint formula? Midpoint formula. X1, X and Y, two coordinates of a point. Okay. So midpoint formula is X1 plus X2 by 2 and Y1 plus Y2 by 2. This is the midpoint formula. 3 points are given in the first question. SMT, you have to check M is the midpoint of ST segment or not. So in the first, S is given minus 3 comma 0 and T is given 3 comma 0. So using midpoint formula, solve it. X1 is minus 3 plus X2 is 3, okay, by 2, okay, comma Y1 0 plus Y2 0 by 2. So you get minus 3 plus 3 0, 0 by 2 0, and 0 plus 0 0 by 2 0. So in the first one, in the first case, M is the midpoint of ST, because the coordinates of M is given 0 comma 0 0, and which is after solving we are also getting the same. So then is M the midpoint of ST? Yes, your answer is yes. Okay. Next, reason for your answer. What is the reason? By midpoint formula. By midpoint formula. Now come to second, solve the second one. In second one, S is given 2, 3 and coordinates of t is given 4 and 5. Using midpoint formula, solve it. The coordinates of m, 2 plus 4, because 2 is the x1, x2 is 4, 2 plus 4 by 2, and 3 plus 5 by 2, 4 plus 2, 6 by 2, 3, and 5 plus 3, 8 by 2, 4. So we are getting the midpoint of ST is 3 comma 4, which is equals to the check M is the midpoint whose coordinates is 3 comma 4, so which is equal to M. You can write here like this is equal to M. So in the second part also we can write yes, M is the midpoint. Yes. Okay. And what is the reason? By midpoint formula. Point formula. Okay. Now the third one is S is given 0 comma 0, and T is given 0 comma minus 10. 0 comma minus 10. Let's check the midpoint of ST. 0 plus 0 by 2, 0 plus minus 10, that is plus minus minus 10 by 2, equals to 0 by 2, 0, comma 0 minus minus 10, that is minus 10 by 2, minus 5, 0 minus minus 5. But here the given M is 0, 5, which is not equals to M. So you write not equals to M. So here you will write no, it is not the M is the, in that case M, no, the answer is no. And here the reason is by midpoint formula. By midpoint formula, what is the M we get here? 0 minus 5. Which one you get? That is, you have to put it here. 0 comma minus 5. The next one is 7, and T is given 6 minus 3. Find out the midpoint of ST. Minus 8 plus 6 by 2. 7 plus minus minus 3 by 2 equals to minus 8 plus 6 minus 2 by 2 minus 1. 7 minus 3, 4, 4 by 2, 2. So let's take it. No. Here is M is given 0 minus 2, which is not equals to our answer. So it is right not equals to M, given M. So here in answer part you write is M midpoint of ST? No. And reason part you write by midpoint theorem first, midpoint formula, and what is the answer you get? Minus 1, 2. Minus 1 comma 2. This is the answer of question number 9. And another part is there, when M is the midpoint of ST, can you find any connection between the coordinates of M, S and T? Midpoint formula is the connection of M, S and T. So we find, you write that, we find the midpoint formula between the coordinates of M, S and T. So the next question is question number 10. Question number 10. Use the connection you found to find the coordinates of B, given that m minus 7 1 is the midpoint of A 3 minus 4 and B x y. So given A, which coordinates are 3 minus 4, B, their coordinates are not given, you have to find out, and also given M, midpoint of the AB, midpoint of AB, that is M is given, the coordinates are given minus 7 1. Okay, you have to find out the coordinates of B, that is x and y. So first, using midpoint formula, what is the midpoint formula? x1 plus x2 by 2, y1 plus y2 by 2. This is the midpoint formula. Midpoint x comma y equals to. Okay. Now here coordinates of M is given. Write it down. Minus 7 1. Okay. Now x1 and x2. What is x1? The coordinates of x coordinate of A, and x2, it is the x coordinate of B, which is you have to find out. So in x1 place you have to put the x coordinate of A, that is A. So 3 plus x by 2, and what is y1? Minus 4, y coordinate of A, minus 4 plus y by 2. Now you have to solve by compare on both sides. See here 3 plus x by 2 equals to, we can write minus 7. If you compare the x coordinate of both the sides and y coordinate of both the sides. So similarly minus 4 plus y by 2 equals to 1 of the right. Now you can solve and find the value of x and y. First you can solve this one. 3 plus x equals to minus 14 and x equals to minus 14 minus 3, you get minus 17. Okay, this is the value of x. And y, minus 4 plus y equals to 2, therefore y equals to 2 plus 4 equals to 6 is the value of y. So the point B, whose coordinates are x and y, and the value of x and y is minus 17, 6. This is the answer.